Hello, welcome to Convergent Dialogues. This is Xavier Bonilla. On this episode, I'm talking with Patrick Roberts. Patrick is the research group leader and director of the Stable Isotope Laboratory at the Department of Archaeology at the Max Planck Institute for the Science of Human History. He has a bachelor's in archaeology and anthropology. He has a master's in archaeological science from the University of Oxford, and he has a DPhil in archaeological science. He is the author of the latest book. The American title is called Jungle: How Tropical Forest Shaped the World and Us. And that is what we talk about in this episode. We begin by talking about his, reasoning for writing the book, and he gives a really nice overview, and it's very concise but really detailed about the history of the Earth, really. He talks about the different periods of the Earth, and he gives an emphasis in each period of how tropical forests are seen in each period, as opposed to just this kind of narrative historical account. He puts much of his focus on what was going on with tropical forest in each period. We spend some time talking about the definition of tropical forest. He gives kind of two main definitions and what their makeup is and what is entitled within a tropical forest. We talk about Pangaea and some of the early landmass of many millions of years ago. We talk about the angiosperm of tropical forest in the Jurassic period, which impacted the dinosaurs. We talk about the importance of early mammals in the Jurassic period and how it impacted growth of mammals after the asteroid. We discuss early hominins and their environment. We talk about early stages of agriculture for early hominins. We talk about island forestation and various human migration. We talk about humans within tropical forest and ancient civilizations. We also talk about, more presently, deforestation and reforestation. And we end by talking about human interference and the impact on climate change. I have to say that this was a really fun conversation. Patrick's a great guy, and I can't recommend his book more highly. He's written a book that is super readable. It's very informational. I mean, I learned a lot reading it. This isn't my field of study, and even though it's not, it was super easy to get the concepts. He goes into great detail about things, but is able to keep the big picture in mind. And so it's a great book. I highly encourage all my listeners to pick it up. And again, the book is called Jungle: How Tropical Forest Shaped the World and Us. And so now I bring you Patrick Roberts. I'm here with Patrick Roberts. Patrick, thank you so much for coming on the podcast and talk about your wonderful new book. Just tell folks real quick who you are, what you do, what you study, and a little bit about the book.
Yeah, thanks. And thanks so much for the kind invitation. It's a pleasure to really be chatting to you today. My name is Patrick Roberts. I'm a research group leader at the Max Planck Institute for the Science of Human History. My interest is in looking at sort of the history of tropical forests and our species interaction with them in the past, and where our kind of stereotypes about these environments come from today. So I've worked in tropical forests all around the world, from kind of Sri Lanka, where I started a lot of this work, through into Africa, near Oceania, and the Americas as well. So I'm really fascinated in kind of the different adaptations our species has had to exploiting, living in these real fascinating environments that are obviously incredibly threatened today.
Yeah. Now, is this your, well, let me tell you, just for listeners, the book is entitled Jungle: How Tropical Forests Shaped the World and Us. Is this your first book? Or have you got a couple in you at this point, or?
So this is my first book for a popular audience. I wrote one more academic book that was more focused on kind of human origins through to kind of agriculture, cities, and conservation issues in tropical forests. But this book really takes an even wider scope, going right back to kind of the first plants, the first forests on the planet, through to how they interacted with some of the first mammals, dinosaurs, and then human origins. And then this book also takes us more into the present day. So why do we have these perceptions of tropical forests as so hostile today? And why do we think that only sort of small groups of humans live in them sustainably today? So that this book kind of has this broader scope, and it's very much written for a more popular, wider audience.
Yeah. Well, reading the book, it's fantastic. And I'm not just saying that because you're on here. It really is a great book. I kind of was struck from the beginning, and it just kind of carries throughout really to the end, kind of a nice thread throughout, which is we kind of see, I guess it's maybe a way in which many people understand, jungles or tropical forests as like, it's a place that exists. And you do a really nice job of saying, how can we kind of look at it, or at least how I read it, of, this is for millions of years and for thousands of years, this was the backdrop. This was the context. This was the environment in which we lived. And, a lot of the stuff that you talk about in terms of the Americas, obviously we had major civilizations, the Mayas, the Incas, etc., that lived within jungles and forests. And so you kind of detail how, living that way for, hundreds of thousands of years definitely shaped us and how we interact with nature and our environment. So it's a really nice thread from the beginning. So we'll get to some of that. So I thought it would be fun, as we were chatting before. The book kind of is in at least 2, maybe 3 parts, as how I was reading it. Kind of this ancient history of just the tangible aspects of forests and jungles, and then kind of more modern history. And at the end, there's a little bit of some conservation stuff, which was really, really, really cool as well. So just give us, in the book, I think in the first couple chapters, you give, you kind of march us through Earth's major periods. And so maybe just give us an overview of the relevant pieces of Earth's major periods, all the different these dispensations, and how we, how we understand that in terms of jungles and forests and botany and all that stuff.
Yeah, of course, my pleasure. So yeah, I'll go through them in a, I'm not a geologist, first of all, but I can try and go through them in a more basic way with a focus specifically on tropical forests and some of the themes in the book. So the book kind of starts in the Cambrian, starting about 538 million years ago. And here we sort of now have evidence for some of the first land plants that are estimated as arriving on planet Earth, on the land, on terrestrial environments, based on genetic models. You might also have heard of this kind of Cambrian explosion, and this is a time when really there were really thriving ecosystems in the oceans as well. But really, this is the first time that kind of things started to happen a little bit more on land as well, when plants started to creep onto the Earth's surface and really start changing the surface of the Earth there as well. This is kind of followed then by the Ordovician period, about 487 million years ago. And here we have the first direct kind of fossil evidence for green land plants. And alongside this, we start to see enhanced weathering. So really these first plants are starting to turn the kind of rock, the Earth's surface, into something that they can use, and something that eventually other forms of life are going to be able to use as well. And actually the changes that they wreak are so intense that by the end of this period, there's actually a massive ice age as a result of kind of changes in the atmosphere that are linked most likely to the kind of emergence of these plants. That's then followed by the Silurian period, around about 443 million years ago. Here we start to get the sort of first fossil body forms of more higher plants, what are called vascular plants. So this means if you've kind of done high school level kind of science, we're seeing structures like xylem, phloem, and true kind of root systems. So the earlier plants are a bit more sort of simple, something you might, sort of things like bryophytes, mosses, things like that. And so in the Silurian, we start to see plants that are a bit more complex, a bit more likely to have even more intensive impacts on the Earth with their root systems. In terms of forests, it's then in the sort of Devonian that follows this period where we start to see a real takeoff. So from 419 million years ago, we start to see the first arboreal forms. So we start the first tree-like organisms as well. The first proto-gymnosperm. So gymnosperm kind of means naked seed, but the first seed plants that are sort of really dominate the planet, obviously today. We see the first true trees as well in this period. And by the end, we're starting to see things that look a bit of forest. The environments on land would start to be a bit more familiar to us. And we also start to see the first amphibians venturing onto land, and also insects as well during this period. So really, it's by this time that we're starting to see ecosystems that look a bit more how we might expect them to look a bit today. Following that period, we have Carboniferous, the Carboniferous period. That's 359 million years ago. This is when I would argue that in some ways we start to see the first tropical forests, i.e. the first kind of forests that are arranging themselves around the equator. They're sort of called the famous coal forests, which is sort of where this period gets its name from. Very swampy and sort of significant woody plants, tree-like species as well, and starting to get really bustling land-based ecosystems as well, starting to get a lot of four-legged animals on land, not just amphibians, but the eventual kind of antecedents of mammals, of reptiles. We're starting to really see ecosystems in what are tropical forests. That's then followed by the Permian period, so 298 million years ago. At this time, we're seeing kind of mass extinctions in sea and on land by the end of the period. And this is a period when the supercontinent of Pangaea is forming, and that's leading to significant changes in land-based environments, the collapse of the preceding Carboniferous forests, what's called a sort of rainforest collapse, quite dramatically at that time. And then after this period, we get the kind of Triassic, Jurassic, and Cretaceous periods, the things that I'm sure many people have heard about in terms of the context of dinosaurs. The Triassic, 251 million years ago, we're seeing some of the first dinosaurs, some of the first dinosaurs even making it to the tropics by the end of this period. We're seeing the first gymnosperm plants, so that's things like conifers, ginkgo trees, cycads. They're appearing and dominating forests that are beginning to sort of come back again after some challenges in the Permian. The Jurassic period then from 201 million years ago, we're seeing increasingly large dinosaurian communities living within gymnosperm dominated forests. Some plants perhaps even adapting, that I think we'll come on to a little bit later, adapting to dinosaur feeding perhaps. We're also seeing the first mammals in this period as well, the first clear mammals as well. Pangaea is also starting to divide at this point into kind of Laurasia, which is kind of the more northerly landmass, and then Gondwana, which is the southern landmass, which Gondwana then in turn breaks up as well. By the Cretaceous period, then we get an ongoing sort of big dinosaur communities still living. We do start to see a new type of plant expanding in the tropics and beyond, the angiosperms, that's flowering plants. So that's basically the plants that make up most of tropical forests, indeed most of land-based ecosystems today. They start to really take off through the Cretaceous. They spread around the planet, and it looks like they have tropical origins really within tropical forest ecosystems at this time as well. And of course, the end of the Cretaceous period, about 66 million years ago, sees the asteroid that really is attributed to ending kind of the non-avian or the non-bird dinosaurs at this time. What follows then, we have the Paleocene, 66 million years ago. This is where we start to see a real explosion of mammals. Mammals were certainly there and diverse, even as dinosaurs sort of were ruling the roost, if you like. But by the Paleocene, mammals are really starting to expand. They're diversifying. They're starting to now dominate the land-based ecosystems around the world. And a lot of this is happening with big expansions of tropical rainforests, not just around the equatorial regions, but around the planet, because there's a general warmer, wetter climate around the Earth. This kind of continues into the Eocene, 56 million years ago. We see the first simian primates in Africa at the end of this period. We see the ancestors of horses, tapirs, and rhinos, things like that start to be initially successful, again, in the context of forests. And then later, as climates start to cool, as forests start to maybe retreat, or there's a little bit of more instability, other sort of mammals also start to take hold. But again, generally a warm, wet climate, expansion of tropical forest-like ecosystems around much of the planet. Then we have the Oligocene, 33.9 million years ago. Here, mammals really start to change. So this is a period when tropical forests start to retreat. They really retreat back to what are the tropics. They had been previously expanded into the northern and southern latitudes, but now they really start to change as climate starts to swing between cool and dry periods and warm and wet periods. And this really changes a lot of mammalian lineages. Things like horses really start to change during this time period. And then the Miocene follows this period 23 million years ago. This is where we start to see the first hominins in Africa. They're kind of our great ancestors, if you like. Often this has been linked to a time, again, tropical forest retreating, hominins adapting to more open environments, striding out, becoming increasingly bipedal. Into the Pliocene, 5.3 million years ago, we start to see hominins like Lucy that are very famous, linked to kind of growing savanna environments, bipedalism in the open, even and later, or just about towards the end of this period, the origins of stone tool use, all linked to this kind of savanna hypothesis, if you like. Then we have the Pleistocene, 2.58 million years ago. This is a period where we start to see the first hominins leave Africa, expand around the world in the form of Homo erectus. We see lots of different hominins that we are increasingly hearing about in major discoveries, Denisovans, Neanderthals, Homo floresiensis, the Hobbit. And then again, towards the end of this period, our own species appears about 300,000 years ago in Africa, before then expanding basically across the entire world by the end of this period, 12,000 years ago. And then we're into our own period, the Holocene, where obviously in the context of tropical forests, we start to see the origins of food production, cultivation, herding practices. We start to see the origins of urbanism in tropical forests. And later then we see European colonialism expand into parts of the tropics as well. And now we're at a point where there's this period that you might have increasingly been hearing about, the Anthropocene. Is that, a viable geological period? And if so, when does it begin? And this is one of the big debates, and tropical forests are playing a kind of key role in this, because tropical forests are so tied into Earth systems. They're tied into our climate. They are tied into plant and animal biodiversity, because there's so much of it packed in to tropical forests. And so changes to these environments can actually have huge knock-on effects for continents, planets, and the entire planet. So that's kind of this last period, this Anthropocene, that there are geologists starting to try and push for it to be formally recognized as its own period, based on a period kind of defined by human impacts on planetary systems. And then the question is, if that is a viable period, when did that begin? When did we start to have these sort of planet-altering impacts? So that's kind of a quick rundown, at least from a sort of tropical forest perspective of the main periods.
Yeah, no, that's wonderful. I think there's two things that jump out to me as you were laying that out. Are there particular markers or events that kind of say, as best we know and how we understand these periods, okay, this is where one ends and here's where something begins, right? Or here's where the new period begins. Is there a certain event, or is there just such changes in the atmosphere or changes in, in how evolution is occurring? How do we know, okay, Jurassic is over and now we're into this next period? And you kind of touched on that at the end there, which, are we in a Anthropocene kind of period now? It's something, quantitatively different than the period that we've known it to be. How do we usually know when we're shifting?
Exactly. So this is really kind of the preserve of geologists, if you like, and ever since kind of there's roots in ancient Greece, the Middle East, and China. There's been a recognition of deep time, right? That perhaps our planet is very old, and that the rocks around us have in some way recorded previous kind of periods. And so sort of since then, but increasing in the 19th century, particularly with a focus from European scientists, there's been a real desire to try and classify these kind of geological layers, if you like. And this is kind of these terms are ways that are trying broad, ordered periods of time that I've tried to use to kind of split up our journey through deep time, if you like. And these are identified on the basis of kind of physical characteristics of the rocks, or the presence or absence of certain fossil plant or animal communities that can really be observed around the planet or around within these kind of rock layers, wherever you stand on the planet to some extent, right? But obviously, as you say, something has to be linked to these boundaries, right? What's creating this change in communities, this change in rocks? And so these distinct boundaries, right, we have to be able to find something distinct to be able to identify them. And so often what happens is it has to be something quite dramatic. So this could either be a major climate shift, it could be volcanic or tectonic activity, or of course, in the case of the end of the Cretaceous, the end of the non-avian dinosaurs, it's an asteroid impact, right? So these are kind of, they're linked to the changes we can then see in these rock layers, and they tell us something about the changes in the Earth at that point in time. But all the time, there's this desire to try and focus on boundaries. And this becomes particularly interesting for the Anthropocene because, yes, we know humans are having a major impact on the planet, but what is a universal marker that we want to pick?
You've already detailed kind of the overview, but how has that changed over time, how we define it in the kind of physical boundaries, but then also the qualities of what makes a tropical forest today as opposed to 500 million years ago, et cetera.
Yeah. So there's sort of two broad ways we can think about tropical forests. So one of them thinks about kind of what is climatically necessary to have a tropical forest or a type of tropical forest, right? So for example, today, tropical rainforests are really classified anywhere you get 2,000 millimeters of annual rainfall, minimum annual temperatures of 18 degrees centigrade, and when there's no significant dry season, right? So these are seen as kind of climatic parameters needed to have an official tropical rainforest. Other parts of those definitions could perhaps include things like specific types of plants, right? So, but they're generally terms that mean they're not limited to a space, right? Because actually in the past, and this is something that I explore in the book, you can have these climatic conditions in completely different parts of the world. That means you can actually have a tropical rainforest, somewhere completely where you wouldn't accept it. So for example, when exploring the Devonian and the Carboniferous, much of the world is what we would conventionally consider a tropical climate, right? It meets the criteria for having that. And that means that we had forests that are reliant on warm and wet conditions well beyond the equator, well beyond the the tropics. And so that's one way to think about it. And that's quite interesting because it allows us to look at kind of the tropical settings of the first plants to emerge, the first trees. They're doing it in what is a kind of tropical world. And so that's kind of an interesting context in that sense. And so we do see that, so I briefly mentioned it when we did that discussion of the periods. We have the most direct evidence for the appearance of land plants from fossil impressions of their bodies or the spores they use to reproduce that are left behind in ancient sediments. And so the first spores we see that are kind of look to be linked to kind of these earlier bryophyte kind plants, things like mosses, things like that, liverworts, things like that, sort of related to those. And they're about 470 million years ago in the Ordovician. We start to see that in Argentina, for example. Recently, there's also been more identified in the Douglas Dam in Tennessee about 460 million years ago. But almost certainly, because of the nature of preservation, right, these are not the first plants on land, most likely. And so scientists have also recently, they've used genetic clocks. And what that means is they analyze the genetics of lots of different plants that are around today, lots of different groups of plants, not just the genetics, but also kind of the body characteristics, the shapes, the morphology. And they compare them in sort of very intensive statistical models to see how long it must have taken to all of those plants to diverge. And then they don't just necessarily compare the modern plants, but they also compare them to kind of fossils at different points in time. And they can use that to produce a statistical estimate of when the first plants most likely were. Obviously, there's quite big errors because genetic change doesn't always occur at a kind of uniform rate. Neither does morphological change, but it gives us perhaps kind of our best guess of when plants probably did appear. And their analyses suggest it's probably about in the middle of the Cambrian period, right? So in the middle of that earlier period. And the argument is, as I briefly mentioned, is that these plants certainly by the Ordovician period, just assuming that they'd colonized about 15% of the current area that vegetation covers on our planet, that they would have actually halved atmospheric carbon dioxide and cooled the planet as a result by at least 4 to 5 degrees centigrade, right? So when you think about, today, recently we've had the IPCC report that's saying the disastrous things that will happen when we reach 1.5 degrees C warming past industrial levels. If you can just imagine the scale of change, right, of 4 to 5 degrees centigrade that having plants on the planet is going to do, you're seeing just the kind of scale of impacts that these plants are starting to have on the planet. And like I mentioned, by the end of the Ordovician period, there is an ice age occurring that's sort of a self-induced ice age, if you like, by these plants, right? But some of them survive around the equator to then sort of expanding it. But it does cause a major shock to the planetary system when they appear. And then with this kind of idea of the tropics, again, it's into a tropical world that we start to get these so-called higher vascular plants with the xylem, the phloem, complex roots that are then having even bigger impacts, right? They're turning rocks into kind of more nutrient-rich soils. They're changing the atmosphere to an even greater extent. And by the time of the Devonian, we're starting to get trees that are obviously having this massive effects. There's this great site at the Riverside Quarry near Gilboa in Albany in New York State, where in the 1920s there were some sort of workers extracting stone for a dam project, and they started to find these kind of log-like shapes just sticking out. And they called this remarkable paleontologist, Professor Winifred Goldring. She was the first female paleontologist for New York State, and she was called to the scene, and her research on these kind of logs showed them to be the first trees that appeared on the planet, and until very recently that remained so, and her work has really stood as this kind of benchmark for understanding these first tree-like structures. And I say tree-like because they weren't necessarily all, they lacked proper leaves. A lot of them were kind of hollow, and instead of kind of a woody trunk, they were sort of a tough hollow kind of structure made from lignin. But they're starting to look like the kind of thing we might think of as a forest. About then 2 to 3 million years later, there's now been a more recent fight nearby, also on the eastern coast of the US, at a site called Cairo. And here they find the same kind of vegetation that were recorded at that site, but they found this extra kind of tree that was known about, and it's called Archaeopterus, this genus. And it was known about previously, but there had never been such a good preservation to really see its kind of full sweep of features. And actually what these latest kind of paleobotanists have shown is that it had a clear set of seed plant features, right? It looks to have been one of the earliest members of kind of seed producing plants that have obviously then, made up most of the plants around the planet today. They had a vast, deep root system that's almost indistinguishable from modern seed plants. It was large, it was upright, it had a thick woody trunk, and it had flat green leaves that could really even absorb more carbon dioxide. So we're starting to see trees that are really then taking this process on to a whole new level. And so kind of in this definition of tropical forest, we can start to, we're starting to see how some of the earliest forest-like things are emerging in what is a tropical world. But the second way of looking at tropical forests is the definition that I use in the book, is forests that exist around the tropics today. So any forest that exists between the Tropic of Capricorn and the Tropic of Cancer. And this allows us to then sort of zoom in on this particular interesting area around the equator. And it allows us to look at the huge diversity of forests that live in and around the tropics today. They're vastly diverse. We often think of, rainforests. When I say tropical forest to you or jungle to you, you'll think of a really dense, lowland, wet rainforest probably. But actually there are forests, tropical forests in New Guinea that grow on the side of mountains that see frost in winter. There are dry tropical forests that really have droughts in certain seasons that exist in many parts of the tropics. So there's a huge diversity of tropical forests that have very different plants and animals, and that also have, would have presented different challenges, opportunities to animals at the time and eventually humans. And so sort of the Carboniferous period is the one that really starts to see the first tropical forest in this definition, right? It's at this time where much of the land sort of because of tectonic plates moving during the Carboniferous, you actually have most of the land is actually somewhere in and around the tropics. And so this is why you have this real expansion of these swampy coal forests that they end up, that has sort of become the name, because you start to see lots of woody like trees growing in these forests that eventually they sort of die into these swamps. But because they're also kind of woody, they're trees, they don't degrade as much. And so that's why eventually, after these processes of high pressure, you get these coal beds around the planet that could be identified as indicative of this kind of Carboniferous period. And that's why they're called the coal forest. And it's obviously kind of sad irony that it's this coal that we've been burning for the last 200 years that is causing a major risk to tropical forests among other environments. So looking at this definition, then we can start to see, how tropical forests in particular have played a major role in things like the evolution of amphibians, some of the other first four-legged animals, the ancestors of reptiles, mammals, eventually dinosaurs, and our own species and its ancestors. And so that's kind of Carboniferous is the first step of this. A bit later on, as I mentioned, in the Cretaceous period, you get the expansion really of angiosperms. And today our tropical forests are really dominated by angiosperms. These are flowering plants. They're the most diverse plants that exist on the planet today. And so the Carboniferous forests wouldn't have looked exactly like tropical forests we think of today. And it's sort of after the Cretaceous period, with the Paleocene, that we start to see forests that actually that were very similar to tropical forests around the world. So I use the example of Cerrejón in Colombia, where a number of scientists have been working, and they found these preserved leaves and types of plants that really do basically look like neotropical forests today. They look like, they wouldn't be out of place in the Amazon basin. They're slightly less diverse. It looks like the climate was slightly warmer, slightly wetter. They have this massive Titanoboa, which is kind of this giant boa constrictor, which would probably make a really good star in a horror film. But you're actually starting, those forests would not look out of place to people that are sort of living in or doing research or visiting forests around the Amazon today. So we start to see, kind of taking that definition of around the tropics, we can look at how these processes influenced how these forests in the tropics change through time, and what role they've played to different animals, plants, and eventually us.
Yeah, no, that's so helpful. I mean, one of the things that I enjoy is in the book and in here now, as you're explaining, you do such a really nice job of explaining all these things. This isn't my world, so it's as I'm listening, I'm taking all the information in. I think it's really, really important to understand what we mean by how we define things and the distinctions and boundaries. And so just one I guess picky thing is, jungles, tropical forests, are these used synonymously? These are synonymous terms, or are there distinctions? Or
yeah, so that's a really good point. So we often think of jungles, right? So I sort of use this in a kind of glib manner, I guess. It's a stereotype that we have. When I say tropical forest to you, you probably think of jungle. But that is in itself a kind of big stereotype. Jungle actually comes from a Hindi word, jangle, and that was used kind of culturally to describe the area outside of a settlement. So it wasn't used to describe a particular type of vegetation at all. It was sort of a more social, cultural thing. And then that was taken into the English language, and then obviously changed a little bit. But it's interesting how it has then come to sort of really define our stereotypes of these environments. And in effect, when I say tropical forest to you, you think of probably a dark tropical rainforest, sort of impenetrable, really quite hostile environment, and this has been built upon in our kind of classic, often prejudiced perceptions, in the form of things like the Jungle Book with Mowgli, the idea that humans should not be in the forest, right? And that they're kind of the preserve of animals, rather than humans, which is in itself got a whole series of racist issues tied up in it. Tarzan is the same kind of thing. And so I use this kind of jungle as a starting point, because it obviously captures attention, because it's how we often think or discuss these types of environments, but also because it actually masks the huge diversity that is inherent in tropical forests and how humans have interacted with them through time. So I would say that sort of in answer to your question, yes, sort of they are synonymous in our popular usage, and even in some forms of academic usage, right? But actually not really. So this is kind of what ultimately the goal of the book is, to try and dive into this. Where do our stereotypes come from? And to really present the kind of diversity of tropical forests and what this diversity has meant for life on Earth, and eventually kind of human adaptations through time as well.
Yeah. No, that's again, I think that explanation is really helpful. I usually just think of, when I think of jungles, I just think of, David Attenborough's voice in my head watching one of his documentaries. That's usually what I think of. And
yeah.
Okay, so let's just talk real quick about Pangaea. So I think for a while, this was like, it felt almost like a fable. It was like kind of a myth of like, oh, we don't really know how the Earth was for a little bit. And then maybe that's just how I remembered it in my head. I mean, but then now it's like, no, like this is a real thing. There was I guess around the equator, just land mass at the center of the globe, and then it started to, because of the moving of the plates and things, it started to spread out over the planet as a whole. And so, what are the best ways to understand Pangaea and what's the other one? The other one after it, as it starts.
Yeah. Well, Gondwana land is one.
Yeah.
One,
and then, is this the, like, we're pretty confident that this is how the Earth's formation was for at least land on Earth, or are there other hypotheses about what happened, and why is this important to understand forest today?
Yeah, no, I mean, you're quite right. So somehow in our popular idea, Pangaea and particularly Gondwana land have this kind of idea of, I shouldn't say Gondwana land, I'm mixing up, just Gondwana, have somehow a linkage to kind of this ancient idea, this kind of almost mythical quality. And in Leipzig Zoo, even, that's why I'm saying Gondwana land, is actually the sort of tropical section in Leipzig Zoo is called Gondwana land, right? It's got this kind of idea that, that is what we link tropical forest to, kind of this ancient, untouched way of life. But what's kind of interesting is nothing could be further of the truth. This is a time of immense change. And yes, I think, to tackle it head on, we do now know that Pangaea clearly was real. We know that tectonic forces have shaped, where the continents have been positioned at various points in the past. And not only that, this movement of tectonic plates and the movement of the land masses has played a massive role in sort of tropical forest evolution and their associated animal and plant life form. So yeah, about 330 million years ago, the world's continents basically amassed into a single supercontinent, Pangaea.
Which period again was this? This was
that's about 330 million years ago. So it's actually during the Carboniferous, although obviously things are constantly moving, but we really see this coalescence in and around the Carboniferous time. And so what's interesting is that this has actually been itself linked to the collapse of these early tropical forests. It's called the rainforest collapse, actually, because this coalescence into a big landmass actually led to a kind of drier, although it was a warmer planet, it was also a drier planet. And the changes have now been considered, or was shown to be so severe, that they actually led to a collapse of these sort of early swamp rainforest ecosystems. And actually it led to one of only 2 mass extinction events ever recorded for plants in the fossil record. So it was a major, issue. It really sort of was a problem for these earliest forests. And by the time of the Permian, again, as Pangaea continues to break up, by the time of the Permian, the sort of number of tree families have been slashed in half. And so there was a real kind of early test. But what, of course, that leads to so often in evolution, it led to change. And so what emerged kind of as the successors to these Carboniferous forests were dominated by gymnosperms. So things like conifers, forests that we would recognize a little bit more after kind of the sort of low ebb of the Permian really started to expand into the Triassic period. So you're starting to have cycads, ginkgo trees, famous ginkgo trees, and there's selection for seed producing. That's what the gymnosperms means, kind of naked seeds that they can kind of, but you're having selection because seeds are a real good advantage, because it allows seeds to lie dormant for a little while. If the conditions aren't great, they can kind of lie dormant, and then they can start growing when things look a little better. So there's kind of clearly a selective pressure that's driven by this change, this kind of coalescence of Pangaea, and sort of by the Triassic period, you're then starting to get forests that we associate with the dinosaurs, but actually would have looked a little more like, particularly most of these kind of more gymnosperm dominated forests now live in the kind of more temperate areas. Think places like New Zealand and Chile, right? But so they don't exist in the tropics anymore. But clearly, this Pangaea process has led to a major change. And then what follows next is then we have angiosperms, which I mentioned later. And these have really been associated then to the increasing breakup of Pangaea, the breaking up into Gondwana land, I keep saying Gondwana land, into Gondwana and Laurasia. And this continues into the Jurassic. So first you have Pangaea, it breaks into two, as I say, forming into northern Laurasia, which kind of includes current Asia, or most of current Asia and Europe, where Gondwana is sort of Africa, South America, India, Antarctica, and Australia, and so that happens first, and then in the Cretaceous this kind of continues to break up into a position where that would eventually is our current formation of the continents. And as this is happening, we have angiosperms that seem to appear in tropical forest settings, probably in the Cretaceous, although there was a recent paper that argued this might be as early as the Jurassic, that their first occurrence was sort of in warm, wet, probably in forest understories. So they're actually sort of the minor bit part players in this kind of gymnosperm forest, but they soon sort of really expand. They take over forests in the tropics. They expand around the world during the Cretaceous, and then they really come to dominate the forests of the Paleocene that I mentioned. That's when we start to see forests that really look like tropical forests. So that is then the angiosperm dominance of those forests. It's intimately tied into this process of tectonic forces. So it's interesting that we often think of this kind of ancient, untouched kind of landscapes, but actually it's a process of major change that's really got a big part to play in how we understand botany, how we understand plant variability around the world today, and of course the origins of tropical forests that we see around the world today as well. So it's definitely yes, it certainly happened, and it played a major role in the evolution of these plants, these forests, and their associated animals.
I want to come to the angiosperm because it's super important. You talk about it a lot, but before that, is when Pangaea started to split and it started to move, you talk about these different kind of cycles that it goes through and how certain things kind of collapsed on its own or couldn't survive. Is that because much of there's a particular climate around the equator, right? Even still today, obviously, there's a very particular climate. A lot of either centered right at the equator, just above it, just below it. There's certain types of ways that life looks around, in and around the equator. And is it just as you get, you start getting pushed, literally, from the plates moving things, getting pushed to the more extreme parts of the poles of the planet, then there's just like a different climate there. There's different, different temperatures. There's different ways, a different environment altogether. That it's like, okay, how this functions at the equator obviously can't function, way up in various hemispheres. So now we, through evolution and through how natural selection works, it's like, okay, we're going to have to find a way. We're going to have to adjust if we're going to be somewhat, and then that's how we're getting these different types of climates and regions, or is there something else to it about that?
It's a little bit more complex than that. So the original climate change is happening. Pangaea is coalescing into a massive landmass, and as kind of climate modelers show us today, the way in which air masses, the way in which ocean currents, the way in which land cover interacts together has a major role in the climate system. Of course, as you mentioned, we have the Earth. It has a certain tilt. It has, certain way it orbits the sun, and that does sort of mean that to some extent there is different amounts of the sun's energy is reaching different parts of the planet at different points in time that will shift through time. But the process of tectonics is having a major impact in how air masses are circulating, in how temperature is being distributed around the planet. And so what actually happens when Pangaea forms, sort of largely around the equator, but also more widely than that, is that in general, the climate just gets drier. And so of the whole planet, so not just Pangaea.
Sure.
And so this In part, yes. I mean, the carboniferous forests were primarily around the equator, but it's actually, it's leading to major changes around the planet. And so these forests really do completely sort of collapse. And by the Permian period, there really is very limited forest cover. In fact, it's one of the, after forests first emerged, it's one of the periods where there was almost nearly no, there were patches, but there really was very little forest cover around the planet before it comes back again in the Triassic. And so this tectonic forcing is having a major role. And again, eventually, by the time that Gondwana splits apart itself, it opens up a lot of the major ocean circulation systems we sort of think about today. So when Antarctica and South America and Australia they split apart, it leads to the ability of oceans to start circulating sort of more north to south, right? And so this actually cools the planet eventually as well. So it's not just sort of things to do with where these plates are. It's also how they're interacting with oceans, how the land masses are changing, and actually at points in time. The tropics were actually incredibly unstable. We don't think of them necessarily that way today, although human-induced climate change is making them increasingly unstable. But actually at the time, sort of the Triassic, when dinosaurs are emerging, the tropics would have actually been less stable than the sort of subtropics, that actually there would have been major, recent studies showing there would have been major lightning storms, major fires, real swings in aridity and heat waves. And so very different of how we think of a tropical climate to today. And so actually, these tectonic processes and the sort of change in the Earth's climatic system is playing a major role and actually changing a lot of things. And again, sort of by the Paleocene, Eocene, there are sort of tropical forest-like forests sort of reaching all the way up to as far as the Arctic, right? So we have mangroves growing around the UK, which is just, sort of bizarre to think of today. So while that latitudinal system plays a major role today, there are a lot of these tectonic changes. This discussion of Pangaea and Gondwana had a major role and did impact how climates varied across the surface of the Earth, that in turn also had massive impacts on tropical forest change as well.
Yeah, no, that's really fascinating. I think, again, the way you explain it makes much more sense of how it changes air, water, and then obviously the land mass that was moving. So as we move a little bit forward, so now it's the kind of the book's great, but the one part that I really enjoyed was the part about the couple chapters, 1 or 2 chapters, I guess, on dinosaurs. And so again, so there's a few questions here. I guess the first question is, I think you already alluded to it about the paper, that the angiosperms were probably during the dinosaurs when they lived, so Jurassic period, or maybe a little bit before that. And again, that's important, as much as I can understand it, is because maybe early beginnings of it is what we have today. So how do the angiosperms connect with these big creatures, big dinosaurs? Why is that important? And then how that's important for, kind of pre and post asteroid that took out not only the dinosaurs, but at least 75% of all life on Earth. I don't know if it's higher or lower, but how do they flourish, and how does that, how do we make sense of that now, and why that's important for us, kind of at this period, so much longer in history?
Yeah. No, so actually, it's not even just the angiosperms. It's also the gymnosperms. So I think one of the things that I really enjoyed about this section, also chatting to paleontologists at the same time, is that we actually, and what was fascinating, that's not my specialism. I don't work in dinosaurs, but I had a great time talking to them about this question, that why don't we think about dinosaur impacts on vegetation and vice versa so much, right? In our popular ideas, we're so used to museums to seeing kind of big dinosaur fossils. Often we focus on the big teeth, the big carnivores, right? And when we consider in movies, we kind of often have this big green backdrop, right? In things like Jurassic Park, that we sort of identify with dinosaurs, but we never really think about it. Like, we never think about how those interactions occurred. And part of that is obviously the preservation. It's very difficult to see how dinosaurs interacted in vegetation, but there are increasing ways that scientists are doing this. But even just to think of, the massive size of some of these sauropod dinosaurs, things like Diplodocus, so dinosaurs called the Supersaurus, things like that with long necks and tails. These are some of the largest organisms ever to walk on the earth. So it's inconceivable not to think that they had no impact on. We know that elephants today have an impact. So of course, these animals must have had an impact on forests and the vegetation growing around them. They ate massive amounts of vegetation, some of these herbivores, right? So what impact has that had on plant evolution? And so that was right. It was really fun to sort of write this chapter and think about some of these questions. It actually begins right back again with the Carboniferous collapse, just briefly, is that, at the time of the Carboniferous forest, you still have sort of amphibians dominating. They're the first animals to sort of expand onto land, but they need to, as they do today, to return to water to breed. They were really reliant on these kind of wet, swampy forests. But these forests collapse. There's a drying happening with the coalescence of Pangaea. And so not only do the forests have to adapt, but the animals have to adapt. And so there's been fascinating research that's shown that this sort of rainforest collapse actually set the stage for other animal life to then become, sort of new players, right? So particularly reptiles, right? Because they can produce eggs. The eggs don't need to be in water. So they're more able to exploit different types of environments. And then getting onto mammals, that changes again. But this process of Carboniferous collapse, it's sort of a negative impact to tropical forests, right? If you like, it's like the taking away of these swamp forests is actually having a major role in reptiles and eventually the dinosaurs. But moving to the dinosaurs themselves, then gymnosperms are actually, they're forests that are really expanding in the Triassic. The forests there are these kind of conifers, the ginkgo trees. And so there's this fascinating case study of this Isaberisaura malensis, which was found by Isabel Berry and her husband in Argentina. And this is a kind of Jurassic dinosaur that sort of looks like it's probably related to these eventual stegosaurs that people might have seen on films, these kind of armor-plated tank-like dinosaurs. But what's most fascinating about this discovery is that the actual stomach contents of this dinosaur were preserved, a kind of mineralized food. And the paleontologists could see that there were seeds preserved in this. There are actually cycads preserved. And what was interesting is that these cycad seeds were actually also, they're quite toxic. So the dinosaur, presumably, unless we've just found the one dinosaur that died when it ate them, assuming that that's not the case, it clearly had an adaptation to eating them, first of all. And secondly, the seed was still whole. So it would have actually been able to pass out of the dinosaur and then, in theory, grow. So you potentially, in this dinosaur, can see an early seed disperser, perhaps, right? That dinosaurs may have had an interaction with gymnosperms where they are having an impact on gymnosperm evolution, and gymnosperms are having an impact on dinosaurian evolution. And certainly, as we start to get bigger and bigger dinosaur ecosystems in the Jurassic period, with some of these long neck, big predators, big herbivores, these are gymnosperm forests that they're living in. There's gymnosperm vegetation as well as ferns that they're feeding from, some of them eating massive amounts of it, right? And so it seems highly likely that kind of wide-ranging movement of these animals, potentially dispersing the seeds, the disturbance of ground is potentially, as it does today among herbivores, potentially somehow the dinosaurs and the gymnosperms might have had some kind of at least loose co-evolutionary relationship. It's even been argued that kind of the cones on some conifer trees, like monkey puzzle trees, might have actually evolved their shape so that they could pass through a dinosaur gut system. So even some of the trees we see around us today might actually have a link to dinosaur herbivory. Similarly, cycads, they might have attracted color-seeing dinosaurs with their colors, right? So that there's potentially, it's very hard to prove, but it certainly seems, based on our knowledge of herbivores today, that there's likely to be a relationship there. Moving to the angiosperms, this is the kind of more famous hypothesis, is that in the 1970s, American paleontologist Robert Bakker actually wrote a paper in Nature that was called "Dinosaurs Invented Flowers," right? It's quite a really big statement. And so his argument was that a change in dinosaur communities between the Jurassic and the Cretaceous period actually led to kind of better conditions for angiosperms. So kind of he argued that you had a reduction in some of these long neck dinosaurs and a growing increase in dinosaurs that sort of like to feed lower down, that would have disturbed the ground more and would have benefited kind of faster growing angiosperms, perhaps. And that in turn, then the expansion of the angiosperms across the planet during the Cretaceous was linked to these kind of new dinosaur communities. Unfortunately, that kind of clear-cut relationship looks to be unlikely. We now think that actually, angiosperms were potentially, they even have earlier origins, but they look to be expanding before any of these changes in dinosaur communities happen. There's not a decline in these long-necked dinosaurs everywhere around, in the Cretaceous. That doesn't quite fit either. And also these kind of more low browsing dinosaurs aren't found everywhere in the Cretaceous either. So there's not quite a direct one-to-one correlation. Actually, many of the herbivores or the big dinosaur ecosystems say relatively similar between the Jurassic and the Cretaceous as well. And we also know that some of these long-necked dinosaurs also fed quite lower down. Some of them fed high, some of them fed low, even with their long necks. But that's still not to say that there isn't necessarily a loose co-evolution, right? So again, you can't deny that these big hulking herbivores would have had an impact on disturbance, potentially on seed dispersal. We've even found angiosperms. There's even been fruits found in the gut contents of some dinosaurs. And there's also, as angiosperm forests are expanding, there are certain dinosaurs, particularly these hadrosaurs, they're the kind of duck-billed dinosaurs, certainly have teeth that look to be quite complex. They're very even potentially as complex as some modern mammalian herbivores as well. I think what's really interesting, right, just to finish on this, is birds are dinosaurs. And so, they share a huge number of anatomical features, and we now know that they're descended from dinosaurs. In fact, they are dinosaurs. And so that there was, in fact, a survival of this lineage through into the Cretaceous. We also know that birds are incredibly important for seed dispersal in tropical forests around the world. Plants often attract them through color vision. They attract them with fruits. And these birds can really connect habitats. They can really even help to regenerate habitats. And so just thinking about the linkage between birds and these environments today, seems likely, especially also given what we know about large herbivores today, that dinosaurs probably did have quite a close relationship with some of the tropical vegetation around them at the time. And I think certainly speaking to a lot of the paleontologists that I spoke with, they seem to see it as quite a very interesting sort of area of research moving forward. That is don't just want to focus on the dinosaur bones themselves, but also their kind of interaction with wider ecosystems.
Before we go to one of the very important mammals, just tell me the significance about when the asteroid hit. Obviously, it took out non-avian dinosaurs, but then also for much of the tropical forest and their viability and how they were able to kind of survive.
Yeah, exactly. Well, this is kind of tied into sort of what happens next. I mean, in the kind of simple story, the idea is that, there were mammals around in the Cretaceous, but they were very small, and they were sort of primarily nocturnal and ate insects. And they were sort of very limited. And the idea being that, the asteroid led to obviously a massive extinction event for dinosaurs. And that it was this process that then allowed mammals to really rise to the top as a product of this. It looks like things were a little bit more complex. So, you mentioned this kind of this most important mammal, if you like. And these things are all kind of tied together in a way. And so, I think you're referring here to the Jeremiah Sinensis, which is this
fascinating mammal. When I was reading it, I was like, well, this is super interesting. There's something very particular because it's one of the pre and post asteroid mammals to survive. Is this correct?
So it doesn't survive post, but it is pre-asteroid, and it's the first. It's the earliest sort of. It allows us to date the split between placental and marsupial mammals, but it is in effect the earliest sort of true ancestor of most mammals alive today. So yes, its lineage certainly continues through the asteroid, and it is probably one of the earliest, although there's been some subsequent finds since, but it has been claimed at one point to be, one of the earliest true ancestors of most mammals alive today. And it's also tiny. It was between 7 and 10 centimeters and probably didn't weigh much more than a kind of standard battery. So in many ways, in some ways, it fits into that general narrative that mammals were really small. They were kind of scuttling away unnoticed at the time the dinosaurs were sort of going around. But we can see from its teeth, from its limbs, that actually it was probably quite arboreal. It was living, up in the trees, probably scuttling around more at eye level with dinosaurs. And actually, more and more fossil finds, particularly in northeastern China, in what's been called kind of, in some ways, there's an area between various provinces in northeastern China that's sort of been likened to Pompeii in some ways, in the way that kind of the layers are preserved. Fascinating preservation. It's where we find there's been a dinosaur find there where they really showed some of the first feathers on a dinosaur. But also later, it's the area where we start to see a lot of the earlier mammal fossils. And we now know that kind of in the Jurassic period already, there was a pretty significant diversity of mammals. There were arboreal mammals, there were ground-based mammals, there were burrowing mammals, and there were mammals that were even swimming in rivers and lakes as well. And there were also gliding mammals. There were flying mammals from around about 160 million years ago. And what's fascinating about these kind of gliders, there's the sugar gliders that are well known as well today, and these would have been very similar. But from the teeth, paleontologists have argued that they have been consuming gymnosperm vegetations. They weren't just all eating insects, but they were actually also consuming vegetation. So again, showing that a lot of this early mammal diversity is perhaps linked to forests in a similar way. This continues by the early Cretaceous. There's also this fascinating mammal called Repenomamus that looks a bit like a badger that actually had a dinosaur found in its gut contents. So some mammals were even eating dinosaurs right by this time. So it kind of puts pay a little. There is more diversity happening at this time than is often considered. And by the late Cretaceous, there's even more examples of mammals, this time seemingly thriving in kind of angiosperm forests, perhaps with teeth designed to eat fruits, nutrient-rich leaves, seeds, and tubers. At a time when fossil angiosperms are expanding as well. And so there is a kind of, quite a lively mammalian community present prior to the asteroid hitting that has perhaps been discounted. And already, I think what's crucial here is that we're seeing that mammals by the end of the Cretaceous had formed a close link to angiosperms as well, which was going to serve them really well when what happened later. But certainly the asteroid then leads to massive step changes in mammalian evolutions. The asteroid hits around about 66 million years ago, and it wipes out these hulking dinosaurian ecosystems that have really been dominating the land's surface. And there's this fascinating site called the Coral Bluffs in Western North America that shows has snapshots of the processes of the periods, the first million years happening after the Cretaceous, as we move into a new warm and ultimately green Paleocene period. So it's got this fascinating series of fossils that show us how mammals are changing at this time. So, the first mammals that escape the extinction event are no more than half a kilogram. 100,000 years later, they're 6 kilograms. 200,000 years later, they're 20 kilograms. Far heavier than any of the mammals that existed prior to the impact. 700,000 years later, we've got mammals weighing over 45 kilograms. So that's more than an adult hyena or a chimpanzee, right? So there's a massive change in mammals happening within this million years after the asteroid. And so again, often this has been linked into the simple idea. It's simply just the death of the dinosaurs that's led to this kind of change. But again, actually, as I alluded to, it seems to be more complex, because what we actually see is this is occurring right at the same time when when angiosperms are coming to dominate forests. So you start to see palms as well, growing taller, more nutritious at this time. They've got fruits, things like beans appear. There's nuts of trees from the walnut family start to appear. Yeah. And these changes are happening at the same time that these fossil changes are occurring in mammals as well. And so as there's this warmer world, Paleocene, Eocene, you're having this expansion of angiosperm tropical forests around the planet, and you're also having an expansion of mammal diversity. So
it's like this coevolution. They're definitely, as they're kind of rebuilding from the asteroid or that event, as they keep trying to flourish and thrive, as the angiosperm are doing that, mammals are also doing that in terms of weight and size, but also in terms of another kind of diversity that happens with how many different mammals and other animals are occurring.
Yes, exactly. Clearly, this relationship with these new and diversifying vegetation forms is crucial to kind of these early mammals that are expanding after the asteroid. Yeah.
So just two other bits now as we move into humans. So as humans come on the scene, or hominins, um, Artie becomes important. So I had Jeremy De Silva on the podcast, and that was he's great, and we talked about bipedalism,
Yeah.
which is, I learned more about bipedalism than I ever did, and I was like, well, I get how this is like really important for us even today. So, and we talked about Lucy, but we talked about Artie, and so from your kind of lens here,
Yep.
how was, you mentioned in the book Artie as well, and earliest hominins, how they were not only in grasslands, but but they were also in tropical forests and what we call jungles. How do we understand as humans come on the scene? They're coming from there's a kind of mixed environment that's going on. So and there's some element of the bipedalism, right? Because as you are able to walk on 2 feet, well, now you have 2 limbs that you can do other things with, as opposed to if you're on all 4s. Well, that makes sense in terms of context, right? You're not just in trees anymore. Now you're, and there's many, what we would anticipate are some types of kind of intermediary species within that cluster based on like the thumbs and how the hands are. And so there's like, some that could do both. They could be on the ground and in trees. And then eventually when we get to, I believe Homo erectus and Homo sapiens, it's mostly just on 2 feet. So anyways, tell us about how our early understanding of hominids in that group, how in their different contexts and environments, how that was changing and evolving for the earliest humans.
Yeah, exactly. So, I mean, sometime between 13 and 6 million years ago, we start to see a new type of great ape, right? And that is, as you mentioned, it's the hominins. This kind of means sort of human-like in a way. I tend to keep the diversity. I say I use human just for our own species, so Homo sapiens, and then call everything else hominins, but it varies. Some people call hominins all humans.
People love fighting about this. It's hilarious.
Yeah, exactly. There's a lot of debates that go on, so I just kind of prefer to stay out of that and just keep it simple from my perspective. But yeah, maybe it would annoy certain people. Yes. So anyway, but regardless. Hominins clearly appear in Africa at some point in around this period, and this is also a time when during the Miocene, as I mentioned earlier, this was actually a time when tropical forests expanded, or tropical-like forests expanded across much well beyond the forest, and actually great apes were really plentiful in Europe, for example, during the early Miocene, associated with this early forest expansion. But then by 15 million years ago, these forests are retreating again, and grasslands seem to be expanding, particularly this new type of grassland called C4 grassland, which doesn't really mean much, but it's just a new type of plant, a new type of photosynthesis that's kind of adapted to supposedly newer, drier changes in carbon dioxide as well, and newer, drier conditions. And so this is the backdrop to kind of the origins of hominins, right? And ever since Darwin, if not before, we've associated the evolution of hominins with then leaving behind tropical forests, expanding into more open areas, right? The idea that bipedalism allows us to travel faster, further. As you say, it frees our hands up. We make tools. We can cook meat. We can fuel our brains more. And we have smaller teeth. Canine teeth become smaller that begin to resemble our own. They're the kind of classic features of hominins. And they've often been linked with these savanna ecosystems. And by the end of that period, we have our genus Homo appearing between about 3 and 2 million years ago. And that's kind of seen as the endpoint. Homo erectus is one of those early members of Homo, and it's sort of striding out beyond Africa by that point, often again linked supposedly to a period of grassland expansion. But I think while there is undoubtedly significance in the increasing of grassland environments over this period, and certainly hominins are interacting with these new expanding grasslands, there's far greater complexity that you sort of alluded to. So Artie is fascinating. Artipidigus ramidus was found 1994, and she was called, the first example was called Artie for short. And in the local Afar language, it literally means root, ground floor. So she was argued to be kind of one of the first hominins, basically. Later, then more fossils were found of another kind of closely related species called Artipidigus cadabra, dating back sort of 5.8, 5.5 million years ago. And so it was argued that kind of she could be one of the first candidates for being the first hominin. She was bipedal. And the teeth and the skull shape are starting to show trends towards hominins and kind of what we look like. But what's fascinating is the reconstructed environment around her is actually quite diverse. There's maybe even closed spring-fed forest. There's tropical forest and woodlands, certainly, and patches of grassland at the same time. And when her teeth were analyzed geochemically as well, it sort of looked to be a preference for more woodland settings rather than kind of towards the grassland areas. And also looking at her sort of divergent big toes and long fingers, clearly she was still well adapted for climbing among trees. So in other words, this clearly wasn't just a complete shift out onto
a mix of both trees and on the ground.
Exactly. And this, the other contenders that, again, have fueled this debate, we have Sahelanthropus, dates to 7 million years ago in northern Chad, also has a mixture of kind of hominin-like and more other ape-like characteristics, is also in a mixed forest, woodland, grassy lake edge environment. Similarly, Aurora tugenensis in Kenya, also about 6 million years ago, again, seems to have bipedalism, but was also eating leaves, fruits, seeds, roots, nuts, and insects, probably in a drier tropical forest setting. So what we have then, as you say, it's a mixture. And what's really interesting is there are some fascinating studies that are in some ways debated, but looking at the use of bipedalism in great apes that are alive today. And so we often think of chimpanzees, right? We think of them as perhaps being the most bipedal, we even see them hunting. But actually, it's actually orangutans that are most comfortably and most frequently bipedal in many ways. And they use it to actually navigate delicate branches and retrieve fruit. So we often think that, bipedalism, it must be linked to kind of leaving trees behind, but actually that's not necessarily the case, particularly when we look at the hominins. So you could also have bipedalism evolving in many different contexts, right, at different times in different hominins. And certainly this even continues into the Pleistocene when we have, hominins like Lucy, even eventually the origins of our own genus. There is still clearly an importance of woodland, an importance of climbing is being maintained. Even when the first stone tools appear, a lot of these stone tools are being used in kind of forest woodland patches in wider grassland landscapes. So I think we're starting to see that this process is much more complex, and that hominin evolution still retained, there's still an importance of tropical forest ecosystems while this is all going on.
Yeah, I think, again, if I remember correctly, when I was talking to Jeremy, he had said that there was a period of where multiple types of hominins were alive at the same time. So it would have been this very strange to us, seeing, if you're in the grasslands or something, you could see Artipidigus or maybe other variants of that, and they're all a little different. They're all their own genus. And it's a very interesting way to think about, we're the only ones that live, and we're really just a hybrid of, maybe Denisovans and Neanderthals and all that stuff. But that at one point there was a kind of coexistence of different types of humans, which is very interesting because there are differences. So before we get to modern history, you talk about this kind of coming out from the early humans, in terms of living in this kind of mixed environment of agriculture and how that works, and how it wasn't just on farms that we think of today, but that much of agriculture was in tropical forest. And so this starts getting into more of the modern stuff of how did people more closer in time compared to the 4 billion years or whatever, but how many times humans were having types of farms or different ways of growing and plants and various things for themselves in tropical forest. And so, how did this happen? And how did we start to then, as humans, live in different climates, forests, but then other places as well as we move closer to current day?
Yeah, no, exactly. Well, I guess even the step before that is our species emerges again, 300,000 years ago in Africa, and it's often seen as the end point of this kind of savanna specialization. But actually, what we're seeing increasingly is that our species emerges probably as a product of numerous interacting populations in different environments in Africa, some of which probably include tropical forests. And certainly, we can now see that as our species expands around the planet in the late Pleistocene, we're not just sticking to coasts, or we're not just sticking to savanna grassland kind of highways, but actually what seems to set our species apart from other hominins is our ability to really adapt and specialize in the use of very extreme environments as well as grasslands and coastlands. So actually, it's in this diversity that really, where we find perhaps what it means to be specifically human. So certainly by the late Pleistocene, we have humans basically on every continent apart from Antarctica, and using almost every single terrestrial environment as well by 12,000 years ago. And then as we move into the Holocene, that's when we start to see kind of what's often called the origins of agriculture, right? An even more intensive influence of humans on the natural world. And this agriculture has often been seen as like a massive break with the behaviors that went before. And part of this, I think, is because it's so stuck in our kind of Euro-American worldview of what agriculture is, right? We think of it, or we define it, actually, the definition of agriculture. We think of it as a settled economy. People are settled, full reliance on kind of domesticated plants and animals. We think of often extensive land clearance and really monoculture field systems, right? That we grow one crop in one field that might span for a significant distance, then we grow for another. So when you think of that, then you obviously think, well, yeah, that is quite a big break from kind of what hunter-gatherers are doing. It also seems unlikely to be very good in tropical forests, right? Because it's involving quite a lot of clearance and probably wouldn't do very well in tropical forests. But actually, that's just based on our understanding of what agriculture is. And if we sort of open up our ideas a little more to look at sort of the behaviors behind that, sort of more what I would call farming practices, perhaps we can start to see a whole new series of possibilities of this type of behavior and sort of the origins of this and how their deep time. So for example, it's more interesting, I would argue, to look at kind of cultivation. So human behaviors that are promoting the survival, reproduction, and growth of certain features in certain types of plants. Similarly, to look at herding as a human behavior that is sort of shaping the mobility, population, social structure, and anatomy of certain animals. And if we think about this, first of all, hunter-gatherers then start to look not so different. So for example, in the tropics from 45,000 years ago, we have evidence that humans are burning forests to sort of maintain a patchwork of resources, to perhaps encourage certain plants. As we'll probably come on to a little bit later, by 20,000 years ago, we have humans moving animals between forests, perhaps as a protein source. Right. So we start to see that if we take that kind of broader perspective, that's not necessarily so different to then, the domestication of plants and animals in many ways. It also means we can start to look at food production in tropical forests, because we don't then need to think about extensive sweeping fields, clearance, etc. We can start to look at, well, where are these contexts where humans are modifying plants and animals in a kind of subsistence system? And so one of the famous places is Cook Swamp in Highland, Papua New Guinea. So this is actually, the excavations here were actually quite a long time ago, in the 1970s, 1990s. And they, even back then, the archaeologists were arguing for one of the earliest farming landscapes anywhere in the tropics and really around the world as well. And before this, when we think of it, the origins of agriculture, because we're thinking of Euro-American agriculture, we're always focused on the Middle East, the Fertile Crescent. We're looking for kind of the origins of barley, wheat, cows, pigs, goats, sheep, because they go on to dominate the agriculture of Europe, the agriculture of North America, and also the slightly more arid environments of there are obviously much more forgiving for archaeological preservation. We find nice examples of charred seeds. We can see how animals change through time, whereas the tropical soils tend not to preserve that kind of thing. It's much harder to find ancient plants in tropical forests as well. And so all of this had led to kind of the tropics, archaeologists gone, not likely to find the origins of agriculture there. But even as early as the 1970s and 1990s, there were some dedicated archaeologists saying, well, hang on, let's see what we find. And so at Cook Swamp, there were sort of 200 trenches dug by archaeologists, and they identified a series of phases of human behavior, sort of between 10,000 and 4,000 years ago, where they were arguing that it looked like there was evidence that humans were modifying the landscape in order to make it better for the growth of some plants, including taro, banana, and even sort of ancestors of sugarcane that we really, rely on as crops today. So phase one, 10,000 years ago, Jack Golson, who was the sort of archaeologist who really made this site famous, he's found a series of drainage ditches. So he argued that this was kind of a deliberate attempt to drain a wetland so that sort of taro root crops and banana trees could grow in the same kind of environment. As I mentioned, it's a bit difficult. So what most botanists work with in the tropics are things like phytoliths. These are kind of the silicon impressions of plant parts that preserve in the sediments, but also things like pollen analysis as well, or starch analysis, even starch granules left behind by certain plants, and they can have characteristic shapes that when looked at under the microscope, you can kind of identify types of plants. The problem is the resolution of a lot of these. A, there's contamination issues, but B, the shapes of these things often makes it very hard to distinguish, is it a domesticated plant I'm looking at, or is it a wild plant? And so that's quite challenging. And so it's hotly, it's been hotly debated whether this earliest phase really is domestication. But regardless, there seems to be a lot of evidence, in a natural ecosystem, you wouldn't find taro, banana, and sugarcane together. They have very different growing conditions. And so it looks like whatever the status of these plants, humans were presumably doing something to alter how they were growing. And also at this time, there's evidence for around the same region for an increased burning of forests, potentially again to maintain patches where you have sort of bananas growing, but more open areas where you might have promote taro growth and things like that. Certainly by phase 2, 7,000, 6,000 years ago, and phase 3, 4,000 years ago, botanists looking under the microscope are finding starch grains and phytoliths that seem to be very much associated with domesticated taro, bananas, yams, and precursors of sugarcane that are being planted in direct association with kind of drains, ditches of humans living around, and also seems to be looking like humans are becoming more sedentary. So when we take this perspective, we're seeing a sort of sequence of humans increasingly sort of interfering, if you like, in plant life cycles. And this region also has a fascinating insight, because we often again assume that agriculture is this major kind of invention that everyone stampeded towards as soon as it existed, right? This is what everyone wants to do. Everyone wants to go and do agriculture, sweeping fields. Well, what's fascinating is that there's a site just over 100 kilometers away from Cook Swamp, at about the same altitude, where throughout the timing of the Cook Swamp sequence, hunters and gatherers just keep on hunting. They're hunting possums, they're hunting cuscus, they're hunting tree kangaroos. They may be burning the forest to promote different plant resources, but they're not, resorting to drainage ditches, right, or anything like this. So we start to see how there really is a mosaic of practices and varied ways to survive in tropical forests, and that food production is one way of promoting different resources in certain settings, but it's not the only way. And also, when we take this perspective, we can see how you can have a trajectory from sort of hunting and gathering through to dedicated food production in the tropics that is perhaps very different to our own perceptions of what agriculture is, but also, as I guess we'll come on to later, it's ways of existing with tropical forests, producing food that does not require fields, does not require big sweeping fields, and does not require massive clearance as well. So perhaps something we need to think about when we think about food production as well today.
Yeah, that last point really kind of also occurred to me as well, because it's like, we have at certain points, we what these types of things are saying is that we know that humans were doing something. They were adapting to their environment. They were trying to find ways to use tools or other things they've been using to have various resources. And it wasn't just, I can't live here, I have to go somewhere else where I can do this in a kind of agrarian type of way. It's like, no, within the environments, there are ways in which you can do that. That also happened as well, but we should not see this tropical forest and humans don't coexist. In fact, they coexisted together for a long time. And so that's interesting in terms of how we look at, kind of up to current day of there are various environments in which we can definitely have various resources. We can have certain types of food, etc. So I think that's super important as we get to the ideas of how we understand modern history as well. So now when we get to modern history, so one of the things that you talk about in these chapters is island forestation in the Lithic and Archaic regions. So Lithic being it seems like most Central American countries, current Central American countries, and Archaic and current South American countries. So, and this was about, I guess, 8,000 years ago. And so there's this concept of how animals were brought to these, what you call islands of forestation and things like that. So just maybe kind of set the stage of what this was and how this is important. I would assume this kind of leads into this understanding of how do we understand how many indigenous tribes in the Americas were able to reside in the, the jungle in these tropical forests, and some still do today in the Amazon and in certain parts of Central America as well. So maybe kind of set that up for us.
Yeah. So, I mean, I guess those terms in particular, they're actually just referring to the colonization of the Caribbean. So it's less of a focus. But I guess this chapter is more about kind of how humans arriving in tropical island ecosystems impacted these environments, right? We, again, in our stereotypes, we think of islands as these deserted, pristine places. Tropical islands are places where people get stranded, right? Where you might have experiments in kind of reality television or survival courses. And so part of this was trying to unpack that and see, the degree to which these environments in the past were inhabited by humans and the impacts that humans had on them. So, islands are often also seen as very vulnerable to human impacts because animals on these environments are often very naive. They're often seen as very kind of, it's easy for humans to hunt them because they have no experience of humans, for example. And also it's hard for plants and animals in these islands to kind of redraw from a wider gene pool because they're kind of isolated. So if things start to go wrong, they sort of really can get into trouble quite quickly and they can't really go anywhere, right? There's no possibility of movement. And so the idea being that humans can start to have a major, perhaps even negative role on these ecosystems when they arrive, particularly if they're arriving with things like agriculture that's leading to deforestation, arriving with animals that can be invasive species that might have negative impacts as well. But I guess building on what I alluded to just earlier is that some of this is happening much earlier than 8,000 years ago. So in Near Oceania, 20,000 years ago, we have evidence that some of the first seafaring arrivals on this kind of, there's this archipelago called the Bismarck Archipelago that's just sort of northeast of New Guinea. And we can see that humans arriving there were moving bandicoots and cuscuses with them, these kind of small furry mammal animals, presumably as a source of protein. We also have evidence elsewhere in the tropics of humans moving plants around. So this is a long kind of history in these settings. But moving into kind of what you were specifically mentioned there, we have in terms of the Caribbean, there are supposedly these waves of human arrivals. So one is this lithic movement, as you mentioned, that's very poorly defined. It seems to be quite controversial. Some people argue it could be some humans coming from Central America into the Caribbean island chain. It's not clear. Certainly this kind of archaic movement later is more secure, and that seems to first arrive in Trinidad and Tobago, which at that time Trinidad itself would have been connected to South America. And so as early as 8,000 years ago, we have humans bringing with them maize, sweet potato, chili peppers, at archaic sites from as early as 7,000 to 6,000 years ago there. And then from there, humans sort of then expanded out into the Caribbean a little more widely, bringing some of these domesticates with them. But they were also moving wild species with them. So it wasn't just like they were just arriving with domesticates and sort of leaving everything else. There's clear evidence they were moving native wild species between different Caribbean islands. So things like wild avocado, wild fig, and certain types of rodents as well. So again, we see this more complex interaction. They're not just arriving and bringing all their own stuff with them. They're actually also adapting to local ecosystems. There's then a later period, this what's called the ceramic period, because it's sort of associated with the arrival of pottery. And this begins about 2,500 years ago in Puerto Rico in the Lesser Antilles, before then spreading out into the Greater Antilles by 1,500 years ago. And these groups sort of then introduced dogs and guinea pigs across the islands as well. They're moving things like the agouti, the peccary, and also things like opossums and armadillos. This group is seen as having increasing impacts. They're seen as potentially leading to increasing clearance of forest, impacts on marine resources. But overall, it's also, again, been argued that, again, they're sort of maintaining wild stands of forest. They're using wild resources. They're still moving wild crops around. And we don't really know what would have happened, because something we'll get onto later, the arrival of Europeans obviously leads to a massive then break with what was happening there for various reasons. So it's unclear yet whether actually these groups living in islands would have been sustainable. And we see a similar situation in the Pacific. So the colonization of the Pacific is often seen as Pacific islands is seen as a very clear, often example of humans arriving with agriculture into kind of pristine island ecosystems. Many of these islands had never been met by humans before the late Holocene even, right? So it's quite a late arrival, and humans are arriving not as hunter-gatherers, but they're arriving with domesticated animals and plants. And so moving from Taiwan there's an idea that humans often associate with this kind of Lapita style pottery, and moving into the Philippines by 4,000 years ago, out into the Bismarck Archipelago I mentioned 3,000 years ago, then into kind of Solomon Islands, Vanuatu, New Caledonia, and eventually reaching Fiji, Samoa, and Tonga by 2,700 years ago. And then later there's kind of a pause, and then around 2,000 years ago, there's kind of some of the descendants of those groups are then moving into Rapa Nui, Easter Island, Hawaii, and Aotearoa, which is New Zealand. And so these groups are, again, they're seen as bringing horticultural kind of what's been termed transported landscapes by Pat Kirch. And the idea of using sort of fire to open forest, promote the growth of taro, yam, banana in sort of garden systems, and also pigs, dogs, and things like Pacific rats, which could have disastrous, in some ways has been argued, could have disastrous impacts on ecosystems, right? Pacific rats particularly have been linked to sort of consuming seabird eggs, and really damaging systems. Pigs have been linked to soil erosion, to kind of expanding invasive plant species. But actually, again, increasingly, we're realizing that these groups were, again, also adapting to wild forest environments. They were maintaining areas of forest. They were managing marine resources, and they were adapting their lifestyles to the different islands they came across, even in some cases planting one type of crop on one side of a kind of slope and one type of crop on another side of a slope because of the way the winds were working. So even in the classic case of kind of Rapa Nui or Easter Island, which we always think of as collapse, which is very much presented as collapse in popular thought, actually there's evidence that humans were actually adapting to change, that they were altering the way they were living on this island. And actually, again, the big break seems to actually really happen when Europeans arrive, with the spread of diseases and slavery and things like that. So these island ecosystems are fascinating for looking at the impacts that humans, or humans in the Holocene in the past could have had on tropical island ecosystems that we often think are very vulnerable. Certainly, there could be very negative impacts, but there's also lots of examples that show that clearly human societies were adapting and changing practices, often to fit with the constraints of these different island ecosystems as well.
Mm-hmm. So I think in terms of, this is kind of humans kind of going to these certain areas, these particular places, and kind of cultivating the area that's there. But then we get to, or kind of at the same time that it's been happening, kind of what you mentioned, this element of colonialism and the impact that has. So first, chart out for us how ancient cities had working communities spread throughout the jungle. And again, like I mentioned, Mayan and Incan and Aztec. I've personally been to the Amazon myself. Cool. And it's a magical place. And knowing that people still live the same way in the tropical forests that they have for hundreds and thousands of years, it's incredible. It's obviously sustainable for, at least those communities. And obviously anthropologists do a lot of this work, and they look at it also, not just in the Americas, but in Southeast Asia and other parts of the world. So how do we understand how these, we're not talking just like some huts, right? We're talking massive cities, civilizations for a long period of time. And then how does that get us to, colonization and then some of the darker chapters of that with humans fighting other humans in that kind of environment?
Yeah. So this has a sort of similar kind of root or narrative as agriculture. Really, what do we think of when we think of a city? We think of Western Euro-American cities. We think of them as compact. Right. We think of them as densely populated. We think of them as the home of kind of political elites, trade centers, manufacturing centers, and we think of them as being fed by agricultural fields that are located somewhere else. They're kind of off in the periphery, and the cities kind of control access to these and really channel the resources to them. And as with agriculture, cities are kind of seen as following on logically from agriculture, and again, kind of sites in the Near East, with some of the earliest cities around 6,000 years ago, as well as cities in the classical world, ancient China. Mm-hmm. Again, thanks to preservation, the ability to do nice long field seasons in these more arid environments, perhaps, or areas that really fit with our own consciousness our own kind of historic, there's often a European obsession with linking to the classical world, for example. We think of this as the only origins for cities, a settlement pattern that really shapes our lives still today. And so for obvious reasons, this assumption is also, when applied to the tropics, led to a sort of idea that probably it wouldn't be very successful. So for example, a long time, the sort of history of the classic Maya was viewed through this lens of kind of inevitable collapse. So you have sort of pre-classic Maya occurring, settlements occurring 800 BC in different parts of North and Central America. So these have cities, there's monumental stone architecture, there's writing, political centers, there's kings, focus seemingly on a use of maize, beans, and squash as kind of really focal crops. And then in the classic period, this really takes off. In the southern lowlands, in particular, you've got Guatemala, Belize, southeastern Mexico between 250, 900 AD, expanding populations, more cities, more monuments, warfare, trade kind of disputes, cities with populations perhaps as high as 120,000 in cities like Tikal, really framed through an idea of kind of how we would think of a city. It kind of fits with our idea of what a city should perhaps be. The problem being there that you have this huge annual rainfall variation, often very long drought periods. In some parts of this area, there's also the geology doesn't really allow for water to be collected, so it's very difficult to keep access to water. And there's then the classic idea that you get more droughts occurring towards the end of the classic period, the terminal classic, that led to droughts. Humans had sort of overreached. They'd sort of cultivating land that was no longer profitable. Crops failed. Landscapes were filled up. With droughts coming, there was not much anyone could do, and the whole system just collapsed. And so that's kind of the sort of classic story of the classic Maya, if you like. But actually, again, thanks to kind of emerging scientific techniques and emerging increasing interest in these areas, we're starting to get a slightly different picture. So actually, even quite a while ago, archaeologists had shown that classic Maya cities were actually not as compact as we have assumed, and that actually they fit with a pattern of what's been called agrarian-based low-density urbanism. So the idea of this is that you have populations spread a bit more across the landscape, and you have fields and food production integrated within that city system. So you have kind of urban infrastructure and residents interspersed within a series of fields as well. And so instead of having a small, very focal point, you have like 100 square kilometers, right? Vast urban areas. And so this really is very different to what we think of when we think of cities. And, to take Tikal as an example, survey has now shown there's a vast network of moats, dwellings, reservoirs, and pyramids that are extending out for up to 200 square kilometers. Not only that, but we've also found that within this more diverse or the more expanded urban system, there's also more diverse subsistence. So it wasn't just focused on maize, squash, beans. There's avocados being grown in kind of orchards or managed forests. There's pineapples, sunflowers, tomatoes, later even manioc being added as well. Forest plants are being managed for medicinal purposes, perhaps even to maintain, soils in certain areas. What's even come to be known in certain areas as forest gardens, the idea that a lot of these fields were actually mobile. So it wasn't just that you had this sort of open landscape of maize, but actually people were allowing the land to sort of recuperate, if you like, even focus on even deer and turkeys being penned, fed, and sort of fattened as well. And even today, when we think about collapse, it's quite offensive to the Maya communities that still live in a lot of these regions, practicing this type of food production called milpa, which is, again, based on this use of multiple crops, mobile fields, and allowing forests to regrow and then come back again. And so this is, that's just taking the case of the Maya. There's also lots of other areas that I mentioned in the book, but particularly in the case of the Americas, then we have to ask, why do we think of this as an example of collapse? Why do we think of this as ending in ruin? Certainly there's major political upheaval in certain part of the classic Maya world, but there are also Maya cities that move to different parts of the landscape. There are, Maya cities from the highlands. There are Maya cities elsewhere near more permanent watercourses that are still there when the Spanish arrive later, that even become part of political negotiations at that time. And you mentioned the Amazon. The Amazon is another classic case. We think of the Amazon basin today, the Amazon forest, as they support really small groups of hunters and gatherers, right? That's what we see there. And that, that's been used to assume that the Amazon never supported food production, never supported anything like urbanism. But actually, again, multidisciplinary research is showing that there are actually things called garden cities. There was lots of examples of food production. There's crops being domesticated. There's manioc in particular. Again, pineapple comes from the Amazon basin. Even potentially types of rice are being domesticated in the Amazon basin. And so also then these urban networks, which again follow a very similar kind of idea that there's nodes, there's a kind of urban network where there's sort of areas of forest that are being maintained, but also, small areas of fields that are left to regrow. There's management of freshwater resources as well. But it's actually supporting a significant population that some have even estimated that the Amazon basin had a population of 20 million by the time that Europeans arrived there, right? So, far many more people than we think of today. And so then again, the question is, well, why have we been left with this stereotypical view? And the answer is yes, the dark, the really sad history that then happens next, that particularly in the neotropics, in the tropics of the Americas, that kind of with the arrival of Europeans, there is a spread of disease among indigenous groups that is even, this, as we can well think of today, this pandemic or set of pandemics is then greatly worsened by slavery by Europeans, that also they wanted to group indigenous people into really focused settlements to make it more easy to administer, but that obviously then made the spread of disease even worse. And of course also warfare. And in effect, basically after 150 years, some of the latest estimates suggest that 90% of the indigenous populations living in various parts of the neotropics had died, right? That is, considering the pandemic we're living at the moment, that is a staggering, it's basically the worst public health disaster ever recorded, right? And it's only, that is the reason why then, there are only small bands left in the Amazon. They either moved away, they wanted to make themselves less visible to Europeans arriving, or simply diseases had wiped them out. Similarly with the cities in the Maya lowlands, they were ruins. People had moved from there, but then the kind of subsequent successes of various Maya communities were then sort of erased, if you like, by Europeans arriving, practice their own types of agriculture, eventually dominating the political landscape. And so this is really the crucial period where we really see this sad erasure of all of this vast evidence for food production, urbanism in tropical forests that then has left us with this kind of idea in Euro-American societies that no one wants to live there, that these environments are hostile, and that actually we're destroying them now because humans should never really go there. And so, the idea that our agriculture and urban expansion into them today in the 21st century is inevitably bad for tropical forests. Well, yes, it is, but that doesn't mean, as you mentioned, that doesn't mean that every single type of food production or urbanism is bad for tropical forests. But we've actually, in many ways, lost, or we've ignored that actually. And that's what's even sadder, is that there are obviously indigenous groups that their oral histories have long recorded these societies, and even their practices today still record these forest management practices, but they've just been so ignored and neglected that we've lost, or that knowledge has been disempowered in many ways, and actually, despite the fact it might hold the key with how we can kind of adapt to these environments today.
Yeah, it's interesting when it's been at least a decade ago now, but my dad's from Central America, and so I've been back to the fatherland a few times, and one time we went to an ancient ruins site, and it kind of blew my mind how much, and I was looking at it like, it wasn't like in the jungle, it was Central America, so it wasn't like the Amazon, but within a type of tropical forest landscape of sorts, and just the irrigation system is just, it blew my mind. It's just like, whoa, like this is very developed. It's pretty incredible. So I always like hearing about the Mayans as my ancient peoples. So
yeah.
Okay, so two other points just to kind of get us to current day.
Yep.
One of the things that you mentioned towards the end of the book is obviously, climate change is a big thing. A lot of people have talked about it now for 50, 60 years now, and definitely over the past 10 years. One of the points that you spend in the book is talking about deforestation and how this has happened. But so I just want to give I was trying to find it, I couldn't find it, but I remember coming across somewhere, and I don't remember if it was in Western Canada or the Northwest of the United States, but that there was lots of reforestation that has happened. We're talking millions of acres, and that it was like one of the bright spots of climate change. Like there's obviously so many issues: ozone layer, ocean acidification, obviously the temperature. There's the list is endless of problems for the climate, unfortunately, and a lot of it is our doing. I don't think all of it, but I think a lot of it. But one of the bright spots I always heard was about in the past, couple of years, there has been lots of reforestation. And so how do you understand the data on deforestation, so that we're losing acres and acres and acres of forest, which is not good for various ecosystems? I'm sure people remember some of the fires in the Amazon, et cetera. There's been plenty of parts of the world where that has been, obviously in Australia, because of drought and increased temperatures. But it's actually going out now out in Wyoming, Montana, and Idaho. Is a lot of drought and fires as well.
Yep.
But all that to say, there is a lot of deforestation. So how do you understand the data on that currently, but then some of the seemingly counter data of lots of reforestation? And how do we understand this in a balanced, tempered way? I'm talking a little bit more of the US because that's where I'm at, but you can spread it globally if you want. How do we understand the kind of balance between these two?
Yeah, so I mean, in terms of Canada, US, it's beyond my area of expertise, but certainly reforestation is a major focus of trying to combat some of these issues. I mean, a lot of deforestation really in the sense has its roots in European colonialism, that kind of the idea of agriculture, or the way that to profitably use this land, we need to clear it. If you think about the plantation system, that has its roots in European colonialism. And so we really start to see, it's the first time when Europeans really get into the Caribbean, South America, and they, start up this horrific process eventually of the transatlantic slave trade. Basically the idea to exploit people from the tropics and landscapes simply just for profit, to make as much profit as they possibly can out of human lives and areas of ground. And this really sees deforestation start to take off in the tropics, particularly with sugar plantations. That's dramatic rates of deforestation are documented, both on the kind of islands off the west of Africa, as places like Madeira, and the Canary Islands, for example, and Sao Tome. But also then, when you're getting into the Caribbean later with British plantation systems, particularly as well, and French plantation systems. That is sort of where we start to see this massive deforestation, with the idea that you can convert tropical forest to something more supposedly profitable. And there is a kind of trajectory that continues. So sort of between 1980s and the year 2000, there really is, a total of over 17 million square kilometers of forest cover was lost from the tropics during that period. And that's area nearly double the size of Europe.
It's insane.
And what's perhaps even more disturbing is, as you say, we might think, we're very conscious of the issues of deforestation. But in the 21st century, forest loss actually continued. And the majority of the world's deforestation is still happening in the tropics, where forest loss is still increasing. In the first decade of the 21st century, actually, forest loss increased every year rather than going down. And so, we are still in a tremendously difficult situation with this. And something we see in the Amazon basin as well, that's only getting worse too. And so there are predictions that say, by the year 2100, Amazon, the Congo Basin, West Africa, the Caribbean, and some parts of Southeast Asia will retain just half of their forest cover. And for places like the tropical Andes, that could be just as low as 20%. So this is, things are pretty bleak. As you mentioned, some people are trying to combat that, right? Deforestation doesn't take into account that people are then trying to plant forests. So you have things like the African Forest Landscape Restoration Project, often criticized for various reasons, but is involving a kind of desire to plant more trees in various parts of Africa to sort of combat climate change, to combat soil erosion, and perhaps in some areas also to foster things like agroforestry. So combining some intercropping of profitable trees with other types of trees. But the sort of problem of that is that once you lose these older forests, you lose a whole variety of ecosystem services, wildlife, and carbon capture, that it's going to take you decades at least to get back, even if you're replanting forests at the same rate. So it's not a panacea. And you know, that's not to say that there aren't successes. Actually, before the current government, Brazil was actually a pretty remarkable light, that it actually stemmed deforestation between 2000 and 2012, so much that it actually offset rises elsewhere in the tropics. So it was actually doing very well in that context.
And even places like Ecuador, again, not the current administration, or I guess they just elected a new president, but the one before that, the one that's there for a long time, all the political stuff aside, one of the things that they had done when they rewrote their constitution was they made the environment have a right. I think it was one of the first constitutions in the world that, you know, they had, I don't know if it was just as much as like human rights, but it had environmental rights, if you will, instantiated in their country's constitution, which is, you know, again, for Ecuador is a small country, but for a country like Ecuador, who has a good percentage of it, is the Amazon. That's super important. And then on the other side of their country, and the Galapagos Islands. So that's really important for a country like that to have in their constitution a right for the environment. It's really nice. So yeah, there are positives, but you make a good point though about some of these older forests. We just can't get that back. We're not going to be able to.
Yeah. So a lot of, you know, as you say, Ecuador, there's also, you know, places like Colombia, Costa Rica have introduced taxes on carbon emissions, and they use those taxes to then fund more sustainable agriculture, fund reforestation, agroforestry. But ultimately, you know, I think, as you even mentioned in the Canadian case, if current carbon emissions around the world are still driving human-induced climate change, it's not only are you losing the ancient forest, but you're also the forests you're planting are not going to be able to survive, or you know, you're facing a whole series of problems in that regard. So there's actually a lot of climate science, although reforestation has become a very kind of in vogue concept. It's sort of a very easy way for us to perhaps transfer our guilt in a way, right? It's very easy to sit in Europe and say, oh yeah, I'll pay this to plant a few trees because that'll offset my carbon emissions. And you know, not to say that there are all negatives to reforestation, like it can certainly do good things, but it's no substitute for cutting emissions, and it's no substitute for doing, you know, trying to stop deforestation. I
think it's very hard because of how much of a trend and hot topic climate change has become, that you know, people want to do their, you know, again, they're kind of, I'll give to charity and then I have to think about it, and I did my good deed. And it's, unfortunately, there's complex and many, many, many issues. So this bleeds into my next two questions, final two questions, which is, obviously you talk about climate change. Obviously I firmly believe the data, and I definitely believe that humans have significantly contributed to this negatively, unfortunately. And I know some people, small groups of people, still debate that and whatever. But isn't it true, though, that the Earth is always changing? We spent the first part of this conversation talking. I mean, now, granted, this is over millions of years, but the Earth is always, its climate is always changing. So if you put humans out for a minute, the Earth is always going to do that. It's going to get warmer. It's going to get colder. It's always shifting and moving. Is it doing that any more times now than it has at any other point? Or is it one of those things where humans, you know, vast amounts of carbon consumption is just accelerating that in ways that is, you know, really unheard of, and almost like a kind of doing it in a way, an artificial way that's not good for the planet? Or how can we kind of just say, okay, normal change of the Earth, but then also, no, wait a minute, we know that how fast in such a short amount of time of humans involvement in this is really making that worse, or how can we parse out these two differences here?
Yeah. So I mean, this is obviously incredibly timely, given that the latest IPCC report came out just this week, and I mean that is kind of, basically the evidence is now completely to see some positives from the IPCC report. It is in fact a report written by scientists with governments, so every single government is now aware of these facts and in principle agrees with these facts, right? So the question is now what they do about it. But so in one positive, this is the first time where really we have seen there is a global consensus, and it's a pretty terrifying consensus that the world is warming faster than at any point, at least in the last 2,000 years, and if not hundreds of thousands of years, and that is being driven by our actions, our emissions. You're quite right. Of course, the Earth has changed in the past. There are two questions there, I suppose. Would we have wanted to live at any point in the past? But also the fact that the speed of which this change is occurring, certainly the speed with which it's happening is pretty unprecedented. But also our abilities to respond are incredibly limited given our current kind of social system, right? Our governments, our economies, particularly in Europe and North America, are so tied into global trade. They're into global investment. If you think about Britain, for example, does not produce enough food to feed itself, and that is the same of most many countries, right? That they rely on imports, they rely on exports. So if you have climate change, you're no longer a group of hunter-gatherers. You're no longer a group of food producers that can witness the environment changing around you. You're no longer a kind of dispersed urban network that has your fields within your urban areas. We are now people that live in cities and towns miles away from our food sources. Many of us can't see the damage that climate change has caused, which is exactly why this has gone on for so long until we've reached this point where everyone has finally got consensus. And why this year is somewhat iconic in the sense that climatically related hazards are occurring across the planet. Right? It's really coming to everyone's doorstep. And we are completely ill-equipped to deal with it in many ways, the pace of change at least. And so that, I think, is why it's so concerning, is that we are in so many ways disconnected from our ecosystems, and our societies are so stuck in certain economic and social political systems that we don't have the capacity to change as flexibly as we could in the past. So that, combined with the climate is changing at an unprecedented rate, while yes, the eventual state might have some analog in the past, our ability to adapt to that change is hindered, or at least for many of us. And so that is also what is concerning, and why we should all be concerned about it.
Yeah, you make a good point there about how we're removed from our ecosystems and our source of food. That dissociation is, I think, I guess the psychology of it doesn't really help us to really take it as serious as we should. For many people. So that's a good point. I hadn't thought of it that way. So okay, last question. You share all throughout the book how and why forests and jungles and all these environments and contexts in the past and in the current moment are essential for our planet, and especially for us included. And so how can humans in present day have a better understanding of our forests, and how can we preserve them to the utmost, not just for ourselves, but for so many multicellular living organisms? You go all the way to fungi, to other mammals, to other types of species and other types of plants and other types of flowers. So this is not just humans. There are many other species implicated in this. How do we currently have better understanding and preserve all of those elements?
Yeah. So, I mean, I think this actually quite neatly ties into the point you just made about kind of perceptions or closeness. I think,
Mhm.
as in the situation with climate change, tropical forests are something that, as you mentioned right back at the start, they're something that we think of perhaps David Attenborough,
Right,
sort of softly talking about. We think of them as, we happily watch documentaries about them. We know how valuable they are to wildlife and to plants. We know how valuable they are to various human societies. We know how important they are for the climate, but somehow they've just always seemed too exotic, too far away, that they're not really our business, right?
Right.
That many of the challenges facing them are actually caused by, emissions being disproportionately emitted in different parts of the world that aren't in the tropics, or by some kind of economic force that's placing market pressures on people that live in the tropics and are having to respond to, constraints of poverty or trying to make a living. And so that is the problem. It's the same as with climate change. Until problems are on our doorsteps, as humans, we actually, although we're a very social species, we actually struggle to empathize with people we can't see, or with situations that we can't experience.
Sorry, I don't want to cut you off, but even not, it doesn't even have to be that way. Even when it is on our doorstep, such as many of the issues with the current pandemic, people are still not getting it, for many ways. And so that's what's so demoralizing in some ways is that it's, even sometimes when it is there's still so much denial, so much rationalization, and that, yeah, it's just very difficult. It's very hard. So sorry, I didn't want to cut in there, but I wanted
I mean, it's a good point. I mean, I think it's, again, with the pandemic, it's the, a virus is invisible, and actually you hear all these tragic stories of people that for whatever reason don't want to be vaccinated, and they're lying in hospital ill.
Yeah.
And they're like, I wish I got vaccinated. But it's, again, until you have that experience of that virus, it is very hard to fully empathize. A lot of us might still happily go and get vaccinated, but actually it's that experience that really for some people is required to actually bring home the reality of it. And that is something that we see, and that is why in many ways 2021 is very interesting, not only from this IPCC report, but also the fact that we are seeing disastrous flooding in Germany. We're seeing wildfires in California. We're in Siberia, right? The whole planet in many ways is for 1 year seeing the disastrous change of climate change. And that is something that perhaps has some tragically uniting force behind it. And so basically why I wanted to write this book, I think for us to, we all know in principle the importance of these habitats, but I wanted to try and make people feel closer to them so that they weren't just some exotic environment, that people really could understand that they are at the core of the origins of plants, that our planet before plants appeared, before the first forest, was very, very different and not a place we would probably want to live. That the history of tropical forests has been key to, dinosaur evolution, mammal evolution, to the origins of our first kind of hominin ancestors, that it's been so critical to life on Earth. That actually then moving even into the history of food production, is the history of urbanism. Tropical forests have been key players in how our species has adapted to the world's environment. It's only going to become more important by 2050. Over half of the world population is going to live in the tropics. These are crucial areas for the future of our species. And then by the end, trying to show that a lot of the interactions between, say, European colonialism and the tropics over the last sort of 500 years have really shaped current economic, political, social, cultural challenges that we face as a planet. And that many of our actions, although we don't necessarily feel like it, are having an impact on these environments and are important. And so I guess that was the whole kind of point of this book, was to try and get past some of these barriers, some of these ideas that they are just exotic backdrops to films, to documentaries, but that actually we all depend on these environments, because if they disappear, they have a critical impact on the climate. And as we see, if we want to limit warming to 1.5 degrees beyond pre-industrial levels, if we lose tropical forests like the Amazon, tropical forests are currently carbon sinks. If they turn into carbon sources, whoa boy, that 1.5 degrees is sailing away from view, right? So they are inevitably caught up in our future wherever we live. And I think that was really what I wanted to do with this book, was to try and make everyone feel a little closer to them. Of course, indigenous people have been saying this for years,
hundreds of years,
hundreds of years, millennia, right? They are well aware of how important these environments are. They are immensely important to them culturally, economically, ecologically. And that's something I also really wanted to highlight, that a lot of this is not because we didn't know, but actually in many ways we willfully ignored it. And so that is also something I think that really needs to be highlighted, that a lot of the routes forward perhaps in our interactions in tropical forests exist out there. There are many indigenous groups, traditional knowledge, traditional ways of managing landscapes that can lead us towards better interactions with these environments. We just have to sort of open our eyes to this vast record that existed prior to sort of European impacts on the tropics.
Yeah, no, I absolutely agree with that. Well, look, for all listeners, the book is Jungle: How Tropical Forests Shape the World and Us. It's fabulous. It's very readable. It's rich with information and data, and there's so much cool stuff in there from our history on the Earth, very, very long time ago, and even now up to current day. So it's really brilliant. So, Patrick, where can people find you? Where can they find the book? Where can they find you online? Find your other research or work? Where are the best places to get at you?
Yeah, so they can find me on the website, the Max Planck Institute for the Science of Human History. The book is available hopefully in all booksellers. So please do. That's obviously another tragedy of the recent pandemic. Please go out there and support your local bookseller if you are interested in purchasing the book. Yeah, and I'm always happy if people have questions. Always happy for people to get in touch and yeah.
Well, Patrick, this was a conversation I was greatly looking forward to, and it was everything I wanted and more. I greatly enjoyed the over 2 hours. You're so generous with your time. I know you're kind of getting over a cold, so I appreciate you really giving me your brilliant mind and your energy and your stamina and just your passion for this stuff. I love the work you're doing, and it was really just a big honor and joy to talk with you about your work. So I greatly appreciate it.
No, my pleasure. Thank you for the invite and for all the interest.
Yeah,
really,
of course.
Really appreciate it. Yeah.
All righty. Thank you.